Welcome all. In this video we are going to see experiment number 8, that is a slip test, measurement of direct and quadrature axis reactance and predetermination of salient pole synchronous machine. So in this experiment we will determine the direct and quadrature reactance of alternator. In a salient pole alternator, the reactance of a magnetic circuit is along its quadrature axis. The alternator is given by an auxiliary prime mover at a speed slightly less than the synchronous speed under this condition. The current armature is when the armature current is MMF is in line with the field poles. The reactance by the magnetic current is minimal. The ratio of maximum voltage to minimum current gives the direct axis impedance, and ratio of minimum voltage to maximum current gives the armature axis impedance. The value of xd and are determined by conducting the slip test. The synchronous machine is driven by a separate prime mover at a speed slightly different from synchronous speed. The field winding is left open and the positive sequence balanced voltage of reduced magnitude and of rated frequency are impressed across the armature terminal. Here the relative velocity between the field poles and the rotating armature MMF wave is equal to the difference between synchronous speed and the rotor speed, that is the slip speed. When the rotor is along the d axis, then it has a position of minimum reluctance, so minimum flux linkage and maximum flux produced links with the winding. So the xd is given by the maximum armature terminal voltage divided by phase current whole divided by minimum armature current divided by phase angle. As the current is small, then the voltage terminal will be I as the drop will be small. When the rotor is along the q axis, then it is max, and then the flux linkage would be max. Then the minimum flux produced, it links with the winding. So maximum EMF, that is xq, is equal to minimum armature terminal voltage divided by phase whole divided by maximum armature current divided by phase. So in this experiment we are going to determine the direct and quadrature reactance of the alternator. We can see in the program you have a power factor, that is PF, we have given 0.9, and xt, that is 1, xq with the quadrature axis, that is 0.6, voltage is 1 and angle is 49, and also the current formula, that is 0.9. If we run this program, we get answer, that is the regulation by 2 reaction method, we get 67.420830. Next, the regulation by synchronous impedance method is 69.47 plus 3.69 D minus 16.1 E. Thank you.